This video looks at what are the effects of damage to these boxes and arrows as seen in aphasia and some other disorders. If you've ever tried to learn another language, you've probably experienced what's not damage, but the experience of these processes not working as easily and as effortlessly as normal. So we'll explain sort of each one and what the breakdown results in. We're not looking at real cases, which are often more complex, but more at discrete damage to one of these boxes. And I'll do my best to mention some natural kind of simulations to help you get a feel for what the damage is and not just the knowledge. First, some essential knowledge about this. Remember that these systems typically don't break completely. It's more likely that they are impaired to a degree. So you might get delayed processing or inconsistent processing. It's less common to get complete breakdown where nothing at all is processed in that area. It's also really important to know that most typically impairment will be spread across multiple areas. Now we're going to be talking about each one in isolation, but more often than not, the damage does not occur in complete isolation. So the reason you need to know that is so that you don't try too hard to differentially diagnose in a really black and white binary fashion. All right, first up, we're going to start at the top left looking at auditory comprehension. And the first process in auditory comprehension is auditory phonological analysis. Remember that this process is supposed to take a signal that comes upstream from the ear, is recognized as speech noise, and determine what are the phonemes being produced in that and what sequence have they been produced in. Now, when this process breaks down, it can be called word sound deafness. And that name makes sense if you think about it. So if auditory phonological analysis is not analyzing properly, it's going to either not recognize phonemes or misrecognize them and generally have a hard time processing speech sounds and their sequence. Therefore, tasks like this with minimal pairs are likely to be mixed up because determining what the difference is between them all relies on a single phoneme. By definition, that's what a minimal pair is, of course. And so the words sax, fax, shax, tax are all going to sound roughly the same potentially to some people with damage in this area. It's extra hard in the case of single words because you don't have a sentence for context. So if someone said, "Oh, I forgot to pay my tax," you could probably hear sax, fax, or shax and still assume that you heard tax. We can kind of simulate this with something called rotated speech. Rotated speech is human speech that has been changed to sound really odd. And if we listen to these, and if I asked you what are the phonemes, what are the speech sounds produced in these, you'd have a hard time doing that. Now, these are actually sentences. It's just that the frequencies have been mixed up. You'd have to read the paper by Scott et al. To understand more about it. And I'm speculating here as to what it might feel like, but that inability to pull out the phonemes and sequence what sounds are where might be similar to this. What does this affect if this is impaired? Well, everything downstream from here and here. So essentially, if you can't accurately recognize the phonemes, then you can't recognize the word, and you also can't repeat it properly. Now, of course, this does seem a lot like hearing loss. It mimics it very closely, except that it's specific to speech. So if you were to ask them to do other auditory processing tasks, they should have no problem. And this is essentially a highly specific auditory processing disorder, but it's further downstream than a general auditory processing disorder. It is specific to speech. All of this is assuming that the person with word sound deafness doesn't have other hearing impairment. And so to diagnose this, you would need to do a hearing screen, a hearing assessment. They might have presbycusis, which is hearing loss due to age, and word sound deafness. In word sound deafness, you can imagine just how much lip reading helps. So having the mouth in front of you helps you really narrow down what are the phonemes that you're hearing, what are the sounds that you're hearing. Now, it is quite rare. I certainly only know one of my patients that I saw over the years who had this. And that could be because it seems to be a bilateral process. So according to the dual stream model, which is very much based on evidence from brain imaging, if we look at this is the left side of the brain, and this is the right, and these are the areas involved. This yellow part here is part of the brain that is highly active during processing of speech sounds. And so if you do have a left hemisphere stroke, it seems likely that the right hemisphere takes over. Here I'm going to be jotting down some really brief and unfortunately really messy notes onto the model itself, and I'll be sure to have this scroll available in the description of the video somewhere. Next up is the phonological input lexicon. Remembering that this process is supposed to take a word, take the phonemes that are passed to it, and then determine whether it's a recognized known word or not. Now, when this is impaired, it may fail to light up, fail to recognize a word, even though it does in fact know it. And this can be simulated pretty well by repeating a word, if you've ever done this as a kid, until it starts to sound a bit foreign. You sort of start to not recognize it. The other possibility is a false positive. So someone hears a word that's not in fact a real word or a word they don't know, and their brain is telling them that they do know it. Or they assume it is a real word because it sounds close to one. So for example, they might hear the word or the non-word bimp, and it activates blimp in their lexicon. This is kind of most likely to happen in testing situations rather than real life, but it is possible. Of course, when that happens, it says, yes, we recognize this word. The semantic system has no entry for it. Or again, if that non-word has activated a real word because it sounds similar, then it's going to light up that meaning, which is not its real meaning, of course. But more commonly than that, you're going to get a situation where they're really slow to recognize the word, and they may need multiple repetitions or a lot of context to understand what the word is. So you might see people with aphasia repeating the word themselves sometimes in order to try to trigger the input lexicon. And this is why people with aphasia also benefit so much from visual support, because comprehension is often possible, but it's just quite slow or inefficient, and having an image there helps them, light up the relevant semantic entry a lot more quickly. And that's possibly because having those features activated in the semantic system, feeds back up to the phonological input lexicon and helps and encourages activation of that correct word. This is often called word form deafness rather than word sound deafness, because they're deaf to the whole word itself as a form. And this will also have a downstream effect on comprehension, but at least theoretically they should be able to repeat words. They just can't comprehend the meaning. The next one is actually the link between the phonological input lexicon and the semantic system, and this is called word meaning deafness. So in this case, recognition may be completely normal, but it fails to trigger the meaning of the word. So in other words, the word does not sound strange to them or unfamiliar, but they can't think, what does that word mean? There's a case study of someone with word meaning deafness from Franklin, Howard and Patterson, 1994. And he says, yes, it's a word, but I don't hear it. So his perception was that he knew it was a word, but he can't quite hear what it meant. An interesting insight into how that felt. Again, this is more likely to be a delayed recognition, where with enough repetition and enough kind of concentration, they can understand a word. And this will affect comprehension, but that doesn't mean they can't repeat known words. Now, only input is affected on this. Other semantic functions should be within normal limits if it's just this process here. Next, we have semantic system impairment itself. Reminder that the semantic system is where the meaning of a word is retrieved for comprehension, or where a concept commences lighting up that lexical representation if they're expressing a word. So for example, they may want to say the word hospital, and those features light up the entry, and they then retrieve it from the phonological output lexicon. Now, damage to the semantic system in a nutshell. I'll give you the short version first and then the longer version for people who want it. In a nutshell, they mix up word meanings, whether it's understanding the word or selecting a word for production. And you'll notice that this would be across all modalities. So auditory comprehension, verbal expression, reading comprehension, and written expression. All of these would have these sort of word meaning mix-ups or failure to retrieve. So you can leave it at that if you like and skip to the next section. Otherwise, here's a more detailed explanation. Remember that I said we could imagine that the semantic system actually had two separate layers. And again, this is just something I'm using to explain this. It's not an official part of the model. But in those layers, we had the red layer, which is conceptual semantics made up of all these other modalities telling us what things are. And then the purple, which is the lexical or word-based semantics, telling us what words mean and how they map to those things in the red. Now, in acquired non-progressive aphasia, such as from a stroke, the lexical semantics are what are primarily impaired, and conceptual semantics are much less likely to be impaired. There might be some deficits, but they're very subtle compared to the lexical semantics. So that's good news. If we zoom into our layered model, it means there's damage here, but you won't lose your representation of what things are. So you will know what a stadium is. You'll just have difficulty connecting what a stadium is to the word stadium. However, in primary progressive aphasia, specifically semantic variant primary progressive aphasia, all of the modalities do become impaired over time. So it is both layers in that case. And some people propose that this is due to damage to the amodal hub, which is proposed to sit between different modalities. If you look at which areas of the brain are most likely to be affected on PET scans in people with semantic variant PPA, you'll see it is the anterior temporal lobes. And depending on the lateral dominance of the pathology, in other words, if it starts more on the left side or on the right side, that'll determine whether they have more lexical or word-based primary progressive aphasia or more other modalities. So that's just an important note about primary progressive aphasia as opposed to an aphasia from other causes. So specifically what's happening, the lexical semantic entries have degraded access rather than damaged entries. So people rarely forget a word completely, very rarely. It's just that they can't access them sort of independently and consistently. So rather than picturing these actual lexical entries going missing, it's probably more accurate to picture degrading and scrambling of these connections between the lexical entries. So picturing lots of scrambling here between the entries. And you can also picture that scrambling happen between lexical entries themselves. So how do these words relate? You've got rock and roll as a type of rock, metal as a type of rock, 4/4 rhythm is a key feature. You've got all these semantic categories and hierarchies. If you imagine that this gets a bit mixed up in people with semantic system impairment, that explains a lot of it. So the symptoms you'll see are emissions, as in the word is missing, or no response, or just saying I don't know what the word is, where there's just insufficient activation on the lexical semantic layer to give you the candidate and retrieve it. There's also coordinate errors where competing concepts are not sufficiently differentially activated, so there's no winner of the activation process. So if you're thinking of mango, you might have normally only the most activated concept would be selected, but there might be multiple that are sort of equally weakly activated. And so you pick the wrong one, and that's a semantic paraphasia. And you can also get superordinate semantic errors, where instead of saying the target, you end up saying the category, because you can't activate the more specific concept. And you can actually have particular semantic categories affected and not others. So some people might have more difficulty with colors or numbers, and other people might have more difficulty with animals. That has been demonstrated lots of times in the literature. So that's a long explanation of semantic system errors. Now let's move on to spoken word production. So we're looking at this bottom left quadrant here. Now imagine someone wants to say something, they think of the concept. So perhaps they're trying to say the word hospital, and they've thought about the place where people go to be treated for illnesses, and it's a big building and there's lots of car parks and it has doctors and what have you. And the semantic system says, yes, there's a word for that, here it is. Let's go and get the phonological data for that word, the phonological entry. But what happens if that entry is degraded? Well, that's one major cause of anomia. You can see that people could still repeat words if it was only the phonological output lexicon that was damaged and nowhere else. So they understand the concept, but they just can't retrieve the word, a word retrieval error. You may also see at times what's called circumlocution, where the person's able to describe what they're trying to say. Maybe it's features of what they're trying to say, or close synonyms, or some of those kind of semantic aspects of the concept, but they're not able to produce the word. And this does happen to all of us at times when we know there's a word and we can't think of it, and we talk around it and we describe it. And sometimes we're trying to inform the person what we're trying to say, and sometimes we're trying to kind of self-cue, self-trigger word retrieval. And lastly, you also get semantic errors here as well as the semantic system. If the damage is in the phonological output lexicon only and not the semantic system, then you will see semantic errors only for verbal expression, because the other areas are not affected. Now, what about the phonological output buffer? If you recall, the phonological output buffer takes the data from the phonological output lexicon where it's stored, and it holds the item temporarily, it arranges that word stress on the right syllable, and it neutralizes unstressed vowels, at least in English. So it's not hospital, it's hospital. It's assembling that in a sequence. When that goes wrong, it's somewhat akin to having all of the ingredients or having all the parts when you're putting some furniture together, perhaps from IKEA, but you're unable to put it together for some reason. You have the set of what you need, but you can't assemble it. You've retrieved the sounds and all of the information, but you can't put it together. You might see phoneme substitution, where a phoneme gets switched out for an incorrect one. If that phoneme is one that also appears elsewhere in the word, or the phonemes are switched within a word, that might be considered transposition or perhaps assimilation. You see fewer deletions of sounds or additions because you have the correct sounds, but you can't assemble it properly. Going back to that IKEA analogy, you're not likely to add additional parts from other furniture or remove them. You're more likely to put them in the wrong order, in the wrong place. There are length effects here, and we're going to go through that in a video on assessment. But essentially, you can imagine the longer the word, the harder it is to get everything into place. So 3-4 syllable words, you'll see lots of breakdowns, errors, transpositions, etc. In a shorter CVC sort of word, you're less likely to see those errors, but of course it depends on the individual and their aphasia. Importantly, if someone has damage to the phonological output buffer and not the phonological output lexicon, they may have knowledge that what they're trying to say is correct or what it should sound like, assuming they have good self-monitoring, but they struggle to assemble the phonemes and syllables, etc., the phonological properties properly. Therefore, you see multiple attempts at a word, and this is called conduit d'approche. And I bet I'm not pronouncing that French correctly. Apologies. You can experience this yourself when you try to produce a tongue twister. You know how it should sound and you're doing your best, but every time you say it, it doesn't sound right. That's very similar. Impairment to the phonological output buffer is also the likely source of phonemic paraphasias, words that sound close to the target but are not. They can be real word errors, so saying bloom instead of broom. A strong theory is that real word errors might just be chance most of the time. So if someone does say bloom instead of broom, it's not because they retrieved the entry for bloom, it's because they accidentally substituted a phoneme. Particularly for shorter words, if you just switch out one phoneme, you are likely to get a real word by doing that, or at least more likely. Or they can be non-word errors. And certainly non-word phonemic errors, when you look across people with aphasia's phonemic errors, most of them are non-words. For impairment to the phonological output buffer, all spoken output is affected because everything comes downstream. So even repetition is affected because you still have to assemble those phonemes and word stress in the correct order. Now, this is not apraxia of speech. I don't mind saying that for a long time I would hear people doing this and assume it was apraxia because I didn't fully understand what apraxia of speech was. This is people knowing the target and just misarranging the sounds, which is different to apraxia. After that process, we should see articulatory programming, where the nicely sequenced plan here is turned into actual motor plans. Damage to this is not actually aphasia. This is where apraxia of speech comes in. So anything below this line is not aphasia. It's not part of the language model. But of course, we can't just finish the model there, because then we're not going all the way to actual spoken production. In reality, apraxia of speech almost always co-occurs with aphasia, but not every time. And I must say, it's pretty poorly distinguished even by experienced speech pathologists. And that's partly because older literature about apraxia of speech also included people who had apraxia and aphasia, and so they might have had a mix of impairments across this. And so some of the symptoms of these were thought to be symptoms of apraxia. So it's a very difficult thing to research and to understand. Now, if someone's having difficulty at this level, it depends what's happening further upstream. So they may or may not fully know the target that they're trying to produce, depending on whether there's damage to the phonological output lexicon. They may have retrieved the target incompletely, and they're having difficulty with apraxia of speech, the articulatory programming. Even if they do know the target, they might be having this difficulty as well with phonological misassembly and apraxia of speech. But we're going to assume, while we talk about these symptoms, that both of those are intact, as you see in pure apraxia of speech, which is apraxia without aphasia. In pure apraxia of speech, you can't convert the planned target into a nice quick motor plan. You'll see people slowing down and almost experimentally discovering how and where to produce each sound. If you recall the Morse code operator analogy from the previous video, the operator has to take a message, an intended message, and convert that, letters and all, into a sequence of tones. So imagine you swap out an experienced Morse code operator for someone with very little experience. They have no established patterns, no ability to plan ahead. They're just looking at the chart for every single letter. And as a result, you'd get very slow, unskilled, separated letters with lots of pauses while they work it out. I'm not going to go into detail on this here, but that's essentially what you see in speech. Slow, effortful, lots of pauses, difficulty with complex sequences where there's lots of consonants together and things like that. That's basically what you see. So the most distinguishing features are slow and effortful speech. There'll be lots of pauses within words and between words because they're working out how to produce those sounds. You'll see schwa insertion in consonant clusters. There'll be disrupted prosody because of all of their attention is going to actually producing the sounds. You know, there's not a lot of resources left to correctly produce intonation. You'll see sound distortions as they try to work out how to produce a particular sound from scratch almost. You'll see sound substitutions where they go to the wrong place or manner or voiced or voicelessness of a phoneme accidentally. And you might see a combination where they substitute and distort the substitution. That's apraxia of speech. Last of all, in this sequence, we have actually sending the signal to the mouth. If that's disrupted at a nervous system level, that is dysarthria. Also not aphasia, of course. Just one more process on this side of the psycholinguistic model is acoustic to phonological conversion. If this is impaired, people will be unable to repeat words correctly, or it will take them a lot of effort. Particularly non-words and unfamiliar words which have to take the outside route. Because if you know a word really well and it's stored in the phonological output lexicon, you won't really need that route. Now this is distinguished from basic auditory verbal working memory impairment. Someone with working memory impairment will struggle to repeat things as well, but they can generally handle single words no problem because it's an auditory memory problem and a single word's not very long. In this case, it's often at the word level as well. They can't correctly or efficiently repeat even a single word, particularly if it's got a couple of syllables. And you might think, how can someone not repeat a single word? Well, conversions feels effortless, but it's not as easy as it feels. You're taking waveforms which have been converted into neural signals. Using the auditory phonological analysis, you are converting that into phonemes and then turning that back into motor plans. Now, the fact that we can do this practically milliseconds after someone else, we can repeat words back immediately. Shows how efficient it is, but it is still a complicated process. Up in the middle here, it's a little bit confusing because we have this visual pathway. You can see an object, recognize it, and then access it in the semantic system. But this is not a language input pathway until you attempt to name it. If you have damage to this pathway, you have what's called visual agnosia, where you don't necessarily recognize images and objects correctly. Visual agnosia is an example of the visual semantic knowledge and connections being impaired, while the others might be intact. Someone can not recognize an object visually, can't tell you what it is, and not because of word retrieval, but because their visual system is not correctly recognizing. But then when they pick it up, they can. I'm not going to go into much detail about that because I don't know much about it. It's outside of our scope of practice. Once again, I've used this source by Lindsay Nichols, an excellent source of detailed explanations. I've also used The Handbook of Adult Language Disorders by Hillis, chapters 6 and 7, and Whitworth is an absolute Bible for this approach, cognitive neuropsychological approach to assessment and intervention in aphasia. Time to test your knowledge. You shouldn't expect yourself to get these right after watching this video once or looking at this briefly. True or false? You can always isolate a single impaired process in the psycholinguistic model. That is false. Often this is not a game of black and white, it's a game of which area is more impaired than one other area. True or false, boxes and arrows are often partially rather than completely impaired. That is true. It's well, not rare, but it's less common that a process completely fails. It's more that it is slow or partially impaired rather than completely. What is the difference between a hearing impairment and an impairment of auditory phonological analysis, i.e. this box here? The difference is that this is very specific to spoken language. A hearing impairment will affect all sounds of all sorts, tones and environmental sounds and music, whereas this is a language processing disorder, so it will only affect speech. Where is the impairment? When a word sounds unfamiliar to someone or they are really slow to understand it. The most likely candidate is the phonological input lexicon. It's not telling them that the word is familiar, or it's being really slow to light up. Where is the impairment when someone produces a spoken semantic paraphasia? They mean octopus, but they say jellyfish. Well, that could be the semantic system itself, or if it's limited only to spoken semantic errors, it could be the phonological output lexicon. The phonological output lexicon also can produce some semantic errors. Where is the impairment when someone produces a spoken transpositional error? They mean to say cavalry and they say cavalry. Well, this is probably in the phonological output buffer. Assuming they correctly know the target they're trying to produce, it just means they didn't sequence those phonemes correctly. And why is visual input typically not affected by semantic system impairment? In other words, why do we not see visual agnosia when the semantic system is impaired? The answer to this is the two layers in the semantic system. So there are lexical semantics, which is the word-based, and then there's conceptual semantics. Visual pathways actually enter conceptual semantics. So if the lexical semantics are impaired in a stroke, that doesn't mean that people forget what concepts are or what they look like. It just means the entries for words get blurred semantically.